this subject is concerned, power system operation is concerned, the first two units deals with mostly with the problems. Okay, understanding the concept and solving the problems. So it is not a theoretical subject. It is not a theoretical subject. Just like that, you can study and you can go. But the subject is very, very simple. The thing is that if you follow the classes daily, then it will be very, very simple subject to study. Okay, I think in the final year, almost for a whole, like four years, I think this might be your one of the very easiest subject that you are going to study like that. But the thing is that you need to follow the problems because in unit one, regarding the unit one is concerned, we are going to solve the problems on economic load dispatch problem. So in that, maybe some 10 methods, many methods are there. Okay, some methods are there to solve the problems. So you incorporate. So what you really need to do is you have to follow up the notes. You have to write the written notes. Otherwise, okay, just like that, if you're seeing the video and audio, hearing the audio, it will be not useful for you to follow up the problems. So the problems we are going to solve, I think the problem sometimes may be somewhat lengthy, but it might be very simple one. The problem, once you know the addition, subtraction, division, and multiplication, I think you can easily solve all the problems. Okay, so it is nothing like a very complex like that. Very, very simple problems we are going to solve in all the like unit 1 and 2. So follow up is needed. And the thing is that already you have studied PS1, power systems 1 and 2. So this subject will be, I think, in power system 1, you have studied about generating station, the complete working of the generating station. Then there is 3 generating station: thermal, hydro, nuclear, gas turbine power plant. So everything you have studied. Then what are the tariff, types of tariff? Then substation, what are the formulation of substation? What are the components inside the substation? Also, you have studied already. Then in the PS2, you have studied about the transmission line model. Okay, transmission system. So all the transmission system, that is voltage, low voltage, high voltage, and extra high voltage, ultra high voltage, and transmission formation like problems also you have to solve. Okay, and one more subject, I think in 3-2 third year second semester you have studied this power system analysis, or otherwise computer methods in power systems. So CMPS, computer methods in power system. So you have analyzed the power system problems. Okay, the bus formulation. Then you have analyzed what are the faults. If fault happens, how we can able to solve the fault. What is the so sending end current? What is the receiving end current? What is the sending end voltage, receiving end voltage? If the fault occurs, how the sending end voltage and the receiving end voltage, and as well as the phase angle is changing. Like that, you have already studied in CMPS. So if you don't study CMPS also, it is very easy to understand the subject. Okay, so don't think like, sir, only few members only we have opted for CMPS. We don't know CMPS like that. But if you are not studied CMPS also, this might be the this subject will be understand. But if you studied CMPS, so somewhat easy to understand. That is the thing. So then fault analysis you have seen in the CMPS. Then so So many buses are there, many nodes are there. So sending end, you are sending, say for example, 11 kV or 33 kV. So in the receiving end, what is the voltage? What is the frequency changes? Like that, something you have analyzed in the power system analysis. So this is somewhat different. This is nothing but the economics. It's deal with most part of the subject deals with economics. So first part, that is first 2 units, deals with the economics. So economics is a subject, I think the basic classes you have studied. So what is economics, like that. So here what you are doing is you are doing the modeling, that is operation of power system economics. Okay, so economic operation of power systems. The thing is that how you are optimizing the cost for a, say for example, even constructing the thermal power plants, constructing the hydro power plants, and next part is distribution. I think distribution subject also you will be studying. This is nothing but the whole, say for example, you're generating the power. So from there in the generating station itself, we are dispatching the power, and also how optimally you are selecting the generators. Say for example, 3 generators are there: thermal, hydro, and nuclear. Okay, thermal, hydro, and nuclear. So normally, which generator will choose for generating the power? Say for example, today's task. Excuse me. So you are the in the future you will be the assistant engineer. You are working as an assistant engineer of the Telangana State Electricity Generation Corporation, maybe. So in that scenario, today task given to you is for generating 1000 megawatt. Okay, 1000 megawatt you need to generate. Okay, so in the case 1000 megawatt you need to generate. So how I said no, 3 generating units. So which generator you should opt so that your cost will be minimized. Okay, so which generators you will opt so that the cost will be minimized. So if you take like thermal power station, you know already we discussed in the power system subject. So thermal power station takes lot of process. Okay, it is not at all an easy task to generate power from thermal power station. Next part, if you take like hydro power station is free. Okay, only the thing is that you need to construct the hydro power station. Okay, so no need of buying fuel for hydro. Why? Because the nature itself is giving water. Okay, so water nature itself we are taking, and we are generating the power using the hydro power station. So next thing is that nuclear power station. Nuclear power station also, if you take like the cost of the fuel. Okay, cost of the fuel, that uranium or so whatever the plutonium. So whatever the fuel we are using, that will be somewhat costly. Okay, it is not very easy to get to the uranium. So this much kgs, 5 kgs or 10 kgs, you will not very easy to get. So it is very costly. So you need to get that fuel. Next, you have to go for the generation. So say for example, the power generated from thermal power station is, and I'm telling about 1 unit. For generating 1 unit from thermal power station, it is costing around 5 rupees. 10 rupees. We can take like 10 rupees. Next, the same thing for hydro power station. For hydro power station, for generating the power, you have to spend around, say for example, for hydro also, even though the fuel is free, so you have to give the money to the employees. Okay, wages to the employees. So that also involved. So with all the things, so operation and maintenance cost is there for hydro also. Generating the power from hydropower station. You need like 5 rupees for generating the power from the hydropower station. Next, if you take like nuclear power station for generating the power from nuclear power station. So even though the fuel is costly, and also the salary to the employers, I already discussed, the salary to the employers, those who are working in nuclear power station will be very, very costly. Okay, so normal, if you take the pay scale of those who are working in nuclear power station, it is 2 times, 3 times more than that of the who are working in the normal power station. Because why they are giving that much salary, in the sense, so life will be threatening those who are working in the nuclear power station. Any because anything can happen in the nuclear power station. Any accidents or can happen. So no one will be ready to work in nuclear power station, even though if you give more amount of salary and all. If something happens, means then the life will be not that much easy. Those who are working in the nuclear power station, whereas other two power station, if you take like thermal power station, hydro power station, so there also fault and accidents will happen. So comparatively, it is very, very minimum. So here also faults will not happen at all the times. So once in a while, so any leakages in the reactor also will leads to damage of their life, whole life. So that is that. So say for example, per unit cost of generating power from nuclear power station is 7 rupees. So first one, thermal is 10 rupees per unit cost. I'm saying an example only. Then for from the hydro, 5 rupees. Then for nuclear, it is 7 rupees. So you want to generate 1000 megawatt of power. Okay, as an engineer, you want to generate 1000 megawatt power. That is the task given to you. So which generator you will select? As a very good engineer, definitely you will select the generator with the least cost. So least cost is automatically you can go for hydropower station. Okay, hydropower station, because the per unit cost of generating power from hydropower station is only 5 rupees. Only hydropower, most of you will select only hydropower because per unit. So you need to generate 1000 megawatt. I'm saying about only one unit, 5 rupees. So 1000 megawatts means imagine that that might be coming in the rows. Okay, so 5 rupees. So all will why you have selected 5 rupees generator? That is the optimal generator. Optimal means that is the minimum cost. Okay, minimum cost unit. Okay, so that you can generate the power. Okay, so normally that is our human nature. Even say for example, if you are going to a near shop to purchase any, say for example, nowadays this um, offer is going 50%. If you want to purchase it, just how will you go? So you'll go to 2 or 3 shops. Okay, so you'll verify all the rates, same material or same thing, shirts, pants. So which one you select? The thing with least cost. Okay, so you compare from all the shops. Okay, suppose I need to purchase a shirt, means I'll compare. So I'll go to some one shop and I'll see all the brands. So this is the cost. Next shop I'll go. So these are the brands. This is the cost. The third shop. So I'll compare which one is the least cost, least shop. In that I will go for the shopping. I'll purchase 1 or 2 shirts for me. It's different, but that is our human nature almost. Okay, so if anywhere you go, so say for example you're going to purchase a product, say for example some products, some chargers or anything. If you want to go and purchase now, you'll go and compare, no, compare this so when comparison, you will see all the specification also. With all the specification made, you found out the least cost product. So that cost you will take. So that is a very good sign for a very good engineer. So that is the optimal. So that only we are going to deal in this units number 1. So we are going to select the optimal generators among the all, or otherwise in thermal, how there might be many thermal station which will operate. Say for example, one thermal station will be located near to the ports or near to the like coal mining area. That if you see the per unit cost, it might be very lesser. Okay, maybe instead of 10 rupees, I said no, might be some 5 rupees or 4 rupees also. In some places, it is very far from the ports, shipyards, or ports, or from the mining place. So transport cost is there. Now you need to carry. Okay, so for generating the power of 1,000 megawatts, you need tons and tons of coals. Okay, you with 1 kg like nuclear 5 kgs, 10 kgs, you can't manage with the thermal power plants. You need tons and tons of coals. So the transportation cost. Imagine about the transportation cost. If you carry in lorries or something else, you need to carry more lorries. So if you carry by railways, I said no, while taking thermal power station. In thermal power station, so mostly they will use railways for carrying your coal. Okay, so in one goods train itself, some 50 or 40 like in that loads they will take, and they will carry that. And if it is say for example, you are exporting from some foreign countries, the coal you are exporting from foreign countries. So how will carry the coal na? Through shipping only, shipping that is shipyards, through the ports and all. So what if you see any like shipping ports? Okay, in that you will be finding more thermal. This coal will be accumulated in the one place. You can also see in some parts of the in southern India. Okay, so you'll be finding in Vaishak, in some other places in Chennai port. Then in this Arabian Sea, Cochin, some ports are there. So if you see that there will be some old yards near to the ports also. So what they will do is they will import. Okay, they will import the very good quality of the coal, and they will dump in some certain places, and they will be selling also. Sometimes government itself will be taking on, sometimes whole private sectors. What they will do is they will bid for a good cost, and they will dump in a dump yard, and those ever you want, you can purchase from that spots. So that also possible for thermal power station. So this this is the PS1. So now the thing is that we have to find out the optimal generators from the all the stations, and so we are going to deal with. So after introduction, you can understand this, how the heat rate curve, cost curve, then production cost. Okay, next is input output characteristics of steam power generating units. Then optimal allocation with the losses. Okay, so so we are going to study the thermal power station with the losses and as well as without losses. Okay, so if you see the practical power station, definitely there might be losses even in generation also, while transmission also. Okay, in generation, some losses might be there, 1 or 2%. Then the transmission, you know, the transmission loss. I think you already studied the transmission subject. So that the losses might be of very more, maybe of 15% to 18 or 20%. It depends on the like so transmission corporations in which they are operating. Okay, so how efficient they are operating. Some transmission corporation might be of their losses might be of very more. Some transmission corporation very keen about losses. They might be reducing the losses up to 12% or 10%, like that. If you visit some of the website of Transmission Corporation, you'll be finding that data. Okay, so what is the losses, how they have reduced the losses, so what are the strategies used to reduce the losses. Okay, so how they are doing optimally, and optimally with optimal cost, how they are reducing the losses also. Because for losses also, you for improve for reducing the losses also, you have to invest more, some fax devices, HVDC, then that also you have to invest more. So if you take like the countries, developing countries like India, so they will be spending very less cost on the fax devices. Very even though in our power system also, the fax devices they have installed, but even though not the fully they are installed, they have installed at certain places. Okay? So with that, they're investing only optimal cost. So with that, how they are reducing the losses. So that also is a very important thing that we have to consider. So that we are going to discuss. Next is what is the effect of transmission losses? Effect of transmission losses. So if the losses is there, so how the generation allocation will be spoiled. Say for example, you're generating 1,000 megawatt. Okay, your transmission losses for example 15%. So 15% means around so 10%. 10% is around 100 megawatt. So 15. So 150 megawatt losses itself it is good. So only 850 megawatts only. Say, see for example, 1,000 megawatts you are generating in the generating station. You are sending for a very long distance. Say 300 kilometers it is traveling. 200 kilometers or to 300 kilometers it is traveling. At the distribution end, okay, they are receiving. Okay, so in between switching substation also there might be that, but in the receiving end you are receiving only 850 megawatt, but you are sending 1,000 megawatt. So 850 megawatt only you are receiving. So 150 megawatt is a deficit. Okay, so for managing that 150 megawatt, what you will do? So you have to generate more 150 megawatt again. So instead of 1,000 megawatt, you have to generate 1,150 megawatt, so that in your receiving end you will be finding 1,000 megawatt. Say for example, some transmission corporation, they are not maintaining this strategy. They are they are not very keen about this transmission losses. So only their transmission loss might be more than 18% or 20%. So 200 megawatt loss for, say for example. So you are receiving in your nearby substation, they are receiving only 800 megawatts. So they need to give all over the this city, all over the city they need to distribute. Okay, so 200 megawatt is the deficit. So 200 megawatt, how to manage? Because generator side, they didn't generate, only they generated around, even though they generated, but the transmission losses 20% it went off. So only 800 megawatts. So with that 800 megawatt, they need to manage. So what they will do is they will go for shut off, frequent shut off for 1 hour, 2 hours within some areas. Okay, so because they have to manage, no, so in their hand only 800 megawatt only. So 800 megawatt they have to manage. So they need to go for frequent shut-off. Okay, so that thing also that. So for that you need to generate more. So generate more means you have to select some other renewable energy resources instead of going for thermal power station. Even though thermal power station, it's acting as a base load, but for managing that 150 megawatt, you have to go for 150 some other renewable energy resources for managing that loss. So why you are opting for renewable energy resource means the cost is very less. So no fuel cost for renewable. So no need to pay for generating the power from like solar cells, that is PV, photovoltaic, then wind, you no need to pay for. Excuse me. Yeah. So yeah, this is also that. So that might be of shut off. So the distribution substation, what they will do is they will go for a shut off. So no other way to go, because they have to manage, or otherwise they need to generate that from some other generators with the low cost. Low cost means they can go for hydro, or otherwise can go for some renewable energy resource, so that your cost might be reduced. Okay, generation. So if the cost of the generation cost might be increasing, means automatically it will reflect your tariff only. Okay, so tariff, say for example, you are paying only 5 rupees per unit cost tariff. So if the generating cost might be increasing, means automatically your tariff cost also will be increasing like anything. Say for example, your the thermal generating station, you're getting the power. Okay, so if the coal cost might be increasing, or some other fuel cost, say for example diesel, it is increasing, diesel rate is increasing, or coal, okay, per kg of the coal is increasing. So automatically what they will do, generation company, they will purchase for the more cost. Automatically what how they will manage the cost, they will collect from us only, because we are the consumers, so we are paying the tariff. Okay, so that they will collect the more some instead of collecting 5 rupees, they will collect 2 rupees more, so they will collect 7 rupees from us, so that they will manage the whole purchasing cost. Like that, it will reflect on our tariff only. So how optimally we are choosing the generators, and how optimally we are generating, and how optimally we are distributing, so that our tariff also will be very, very less. It will reflect in our tariff also. Okay, so that all thing we are going to discuss in the unit 1. So regarding this unit 2 is concerned, unit commitment and optimal power flow solution. So in this so now we have allocated the, so we have chosen the generators. Okay, which generator is least cost, like that we have chosen the optimal generators. Now we have to commit means we have to select that particular generating units to that particular distribution system. Say for example, one area 1000 megawatt, another area 500 megawatt, another area another district 1500 megawatt, another district 2000 megawatt. So like that, it might be okay, varied, depends on the districts. So we have to commit that certain generating units, which for 1000 megawatt, so this many units, say for example 1 2 3 3 generating units for this particular district, some 5 generating unit for this particular district. So you have to commit. So how to commit, that we are going to see in unit number 2. Next thing is that so how optimally you are committing, that also one of the matter that we'll see once we'll discuss that topic. Next is optimal power flow. I think this is somewhat little bit continuation of your CMPS, but no need to worry about that. So in this optimal power flow, how optimally the power is flowing from one bus to another bus. Say for example, your central distribution station is somewhat far away from your area. That is traveling for in say in this district some okay distribution station will be there. So from that only you will be receiving the power to your nearby distribution station. Okay, so in your nearby distribution station, okay, so from there it is traveling to nearby distribution. Say for example, from your nearby distribution substation to that district substation might be of some 50 kilometers far. So 50 kilometers it has to travel. Okay, so 50 kilometers it has to travel. So that 50 kilometers, some losses might be there. How optimally you're traveling. Say you have to follow some shortest route to grab that power. Okay, so if you go for increasing, okay, so how optimally you're transmitting and how how optimally you're transmitting the power, and with the because you have to reduce the losses. If you travel, so many buses might be there, many buses or many nodes might be there. So if it is traveling to some other areas and again coming to our areas, means the losses might be more. So how optimally you can carry that power to that particular point. So that also you should plan. So that that is nothing but optimal power. Okay, so that also some initial some introduction part we are going to discuss about this unit. So next, coming to the unit number 3 and 4, that is nothing but load frequency control. Okay, so now we have transmitted. So frequency, how it is affecting. Okay, frequency, how it is affecting depends on the load. Depends on the load. So there might be the frequency variation. So how optimally that frequency is managing. Okay, so that we are going to see in this unit, that is unit 3 and as well as unit number 2. So if it is a single area, so how the frequency control is possible. Then if it is multi-area, 2 or 3 areas, okay, if it is multiple areas is there. So say for example, where we are living this, that is one area, some other. So if it is that areas are interconnected, how the frequency is affecting. Okay, so how we can able to manage with that frequency changes. So what are the devices to be installed, like that in detailed analysis we are going to analyze in this unit number 3 and 4. So next, coming to the unit number 5. Unit number 5 is reactive power control. So in this definitely the reactive power injection might be that in the system. Okay, so unused power or sometimes what it will happen is, so you will be sending some power. Say for example, 1000 this much voltage. Say for example, 11 kilovolt, 11 kV. You are sending from the sending end. So in the receiving end, it might be of somewhat more also sometimes. Okay, so you'll be receiving some 15 kilovolt also. Okay, so that thing how I think you studied in power system subject, Ferranti effect. So in that, and also reactive power injection might be there. So in that, so how to manage that reactive power? So what are the compensating devices? Okay, devices for managing that so how the load gets compensated. Okay, so that compensation, what are the types of compensating equipments? So everything. So shunt series compensation, I think already you studied in your HVDC and PAT subject. So in that, some certain things, how to control this reactive power, that also we are going to see in this unit number 5. So next topic is voltage stability problem. So how it will affect the voltage profile, voltage stability profile. So how to manage that voltage? How to manage that voltage profile? So that everything we are going to see in this unit number 5. Okay, so this all about this subject, power system operation control. So it might be very interesting subject. Okay, might be very interesting subject. The concepts, how we are relating, and we are going to okay. So from the solution, we are going to formulate the okay derivations. Everything we are going to derive based on the this economics. And this frequency changes, everything is all connectivity. It is all connection between your power system as well as this subject. Okay, power system 1, 2, and CMPS, everything is connected in this subject. So that we are going to deal with all this thing in this semester via this subject. Okay, so I think this the introduction is over for this power system operation control. In detail, the detailed thing we will see in the forthcoming class.